In this video, I will explain the chain rule, which is the basic theory for backpropagation. Okay, we start by derivative. From the definition of derivative of function f, we have this f prime x, which is the derivative of function f at point x, is equal to limitation epsilon go to 0 fx plus epsilon minus fx over epsilon. So from this definition, we have this as well. Fx plus dx equal to fx plus f prime x times dx when dx is very tiny value, infinitesimal value. Okay? Right. Then what happens when we have a composition of functions? There is input x, and this input x goes through a multiple different function from f1 to f bracket capital L, and then we have the output y. So y is equal to L minus 1 bracket 1 x. So let's say this is function f. Okay, so the function f is composed of capital L different function, sequence of function, and we want to find the derivative of function f at point x. Okay. Right. To explain the detailed process, I want to introduce few more notations. Let's say x1, x2, up to x bracket L denotes the output right after function f1, f2, up to f capital L. Okay. Right. So I will use this definition to obtain the f prime x. Okay. So let's imagine we have x plus. We have x plus dx as an input, and which input goes through f1 through fl. Okay. So here, what is the value? Which will be f1 x plus f1 prime x times dx from the definition of derivative. Okay, and from the notation, this value is x1, and let's say this is dx1. Because we can make dx very small, and we can make this value close to 0 as much as we want. So we can essentially always guarantee that this value also very tiny. This value also infinitesimal. Okay. So from this, we can understand the output of right after f2 function is equal to, from the definition of derivative, f2x1 plus 2 prime x1 times dx1, and since dx1 was f1 prime x dx, we have this. So this is the equation right after function f2. In this way, we can complete the function value, which is equal to f l x l minus 1 plus f l prime x l minus 1 dx l minus 1, which is essentially equal to f l x l minus 1 plus f l prime x l minus 1 times f l minus 1 prime x l minus 2 times f l minus 2 prime x l minus 3 up to f1 prime x dx. Okay, so this is the output y. So, and this is essentially equal to fx. So we have this form. Y is equal to fx plus f prime x dx, where this f prime x is equal to fl prime xl minus 1 times fl minus 1 prime xl minus 2 f1 prime x. So this is the derivative of f at point x, which is multiplications of fl prime, fl minus 1 prime, fl minus 2 prime, up to f1 prime. Okay, so this looks like kind of chain reaction. One tiny derivation of input, one tiny movement of input will be multiplied sequentially each function as much as the derivative of each function. Okay, so this is called chain rule for the composition of functions, and which will be the basic of backpropagation algorithm for neural network. Okay, so I just explained the chain rule for scalar functions. We can easily extend the scalar function result to multivariate function and multivariate output with Jacobian. So maybe you already know the definition of Jacobian. If you don't know the definition of Jacobian, please stop the video and search the Jacobian from Google. There are a bunch of nice materials that can explain Jacobian very easily to you. Right. So let's use J to denote the Jacobian of function f at point x. Okay, right. Using the Jacobian, we can define the chain rule. So let's say x plus dx as the infinitesimal perturbation of input x, which goes through function f, then the result will be f(x) plus Jacobian of function f at point x multiplied by the perturbation vector dx. Again, we can define this perturbation vector as small as possible, and we can make this vector arbitrarily close to 0. The Jacobian matrix multiplied by the dx vector, still very tiny vector, still infinitesimal. Okay, same as f prime x dx. So we can follow the same logic as before we use for scalar functions. We can derivative for the composition of functions as follows. Gradient of fx0, which is equal to Jacobian fl xl minus 1, Jacobian of f l minus 1, x l minus 2, Jacobian f1 x. That's it, which is the chain rule for multivariate input function.